diagram, in tree diagram, you basically, a tree diagram is useful when you are doing a problem with multiple steps. So for example, you are doing multiple tosses of a coin. You toss a coin one time, you get a head and a tail. You toss again, you get a head and a tail. So this one also is a head and a tail. And then you toss again, it's a head and a tail. You toss again, it's a head or a tail. You toss again, it's a head or a tail. You toss again, it's a head or a tail. Now at each step, the probability of getting a head or a tail is 0.5. So this gets, you then write that 0.5, this will be 0.5, this will be 0.5, this will be 0.5, and this will be 0.5. Then the final sample space, this way it becomes very clear that after 3 runs, the sample space is going to be, you just count this, 1 2 3 4 5 6 7 8. The final sample space is going to be 8. Now if you go down this path, you multiply, and the total probability vertically needs to be 1. So this needs to be 1, this needs to be 1, this needs to be 1. For each. So now, for example, it's the question is, what is probability of flipping the same side 3 times in a row? So we can get 3 heads. We can get head, 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 head. So the probability of that is just going to be, probability of getting 3 heads is going to be 0.5 times 0.5 times 0.5, or easier way is 1 by 2 times 1 by 2 by 1 by 2, that is 1 by 8. Same is the probability of getting 3 tails. You just multiply this, and that's also going to be 1 by 8. Now you can see that total probability, because we are not going across the line but from this to this, total probability now you will add. So you can get either 3 heads or 3 tails, and that is why the total probability becomes 1 by 4. The same thing can be used when the outcomes are not equally likely. For example, we don't have the coins are not fair, and they have different probability of getting heads. And so for example, we are using a tree diagram in the sense that two people are throwing 2 dice, and game is won by the person who throws 2 sixes. Game is won by person who throws 2 6. Person A, or we call him Pat, starts the game. So let's draw the probability tree here. So we have the first round where 2 things can happen: Pat wins or Pat loses. Now what is the probability of Pat winning? This is getting the probability of getting 2 sixes, which is going to be 1 by 36. What is the probability of Pat losing? This is 35 by 36. So so the simple probability, if a question is what is the probability that Pat wins in the first try, well, that's only 1 by 36. But after that things starts getting murky. So now Pat loses, and only when Pat loses, that's when the Chad will try. So then you have Chad wins or Chad loses. And then if the Chad loses, Chad wins, then he wins. But Chad loses, that's when Pat tries, and then Pat can win or Pat can lose. So what is the probability of Chad winning on the first try? That is also going to be 1 by 36, and this is Chad losing is 35 by 36, and Pat winning is again 1 by 36, and Pat losing is again 35 by 36. Okay, but what is the probability that Pat wins in first or second try? So probability that Pat wins in first or second try. So in this case, what you have to do, the first try is 1 by 36, but then we are going down the hall, down the line. So now we have to calculate now we have to calculate this probability of the second time. The first time is this is the first time, right? So this is the first time, but then we're going this round. So this one we will add with this. So we'll just go down this hall, down this line. So this will Pat losing probability is 35 by 36. The next round is the Chad will also has to lose, so that is 35 by 36, and then Pat has to win. So we're going this, and then it is going to be 1 by 36. Now we'll take a further step, and that may get requires a sort of progression formula. What is probability that Pat eventually wins? Now this is a sequence of events, and the sequence of event goes like this: is 1 by 36 plus second step is 35 by 36 square times 1 by 36. Now the fourth step is not going to be third, because as you can see that if you take this forward, what happens next? Chat loses, then Chat wins, then Chat loses, and then Pat wins, Pat loses. So Chat losing also comes here as 35 by 36, and then this is 1 by 36. So for Pat to win in the third try, this is Pat's first try, this is Pat's second try, and this is Pat's third try, but you also get two Chads in between. So for Pat to win in the third try, this is going to be 1 by 36 plus 35 by 36 times this one, which is 35 by 36, times this one, which is 35 by no well then this one, 35 by 36, then this one, this is 35 by 36, then this one, this is 1 by 36. So this is 1 plus 36 plus 35 by 36 to the power 4 times 1 by 36. So node number 3. So this all so there is a formula for calculating this, which is a upon 1 a upon 1 minus r square, where a is this is the probability of winning. This is 1 by 36. 1 by 36 divided by the probability of losing, which is 1 minus r square, which is 35 by 36 square. This comes out to be 0.507. So this is, and you can see that the Pat has a slightly higher chance of winning as he started first, but that is how you calculate the probability of formula. So the thing to remember here is this formula, a minus 1 minus r square, and the probability of um, um, Chad to win would be just 1 minus this probability. Going to another probability or Bayes tree calculation is a more complex example, which is um, uh, um, boys and girls playing soccer. So we have boys and girls playing soccer. So suppose you are giving a bunch of students in a class and they play soccer or not. So you're trying to create a Bayes tree here. So there is a probability that boys and girls, and there is a probability of boy, obviously there is a probability of girls, and then they play soccer or they do not play soccer. Same as with girls, they either play soccer or they do not play soccer. Okay, so and this here is soccer, so you can, this thing here can also be written as probability of soccer knowing that you are a boy, and this is a probability of soccer knowing that you are a girl, and we're going to call this as S prime. So this will be probability of S prime knowing that you are a boy, and this is a probability of S prime knowing that you are a girl. So and so what is this thing? This is probability of soccer and boys, which is going to be just multiplication of these two numbers, which will be probability of soccer knowing that you are a boy times probability of boy. So this is the Bayes formula. So now let's see, you are given some numbers. So let's say that 40% are boys. So probability of boy is 0.4 and probability of girls obviously will be 0.6. And then you also given a probability that that 30% of boys play soccer. 30% of boys play soccer. So probability of soccer knowing that you are a boy is going to be 0.3, and 60% and 40% of girls play soccer. So probability of soccer knowing that you are a girl is 4, because 40% of girls play soccer. Now we know that in the T diagram the numbers should add up. So if 30 is, this is 0.3, then 70% of boys should not play soccer and 60% of girls should not play soccer. But while we're doing this, we also should calculate this number here, which is the probability of not playing soccer and girls. This is going to be just a multiplication of this, which is going to be 0.0, which is 0.28. This number here is 0.3 times 0.4, this is 0.12. Similarly, probability of soccer and girls is going to be 0.4 times 0.6, 0.24 is going to be 0.6 times 0.6, that is going to be 0.36. So far what have we known? We have known this thing: probability of soccer given that you are a boy, right? Probability of soccer given that you are a boy, we know that. Or we also know that probability of boys playing soccer, probability of boys not playing soccer, probability of girl playing soccer, and probability of girl not playing soccer. And obviously this is all going to add up into one, because you are a boy and a girl, you play soccer, you don't play soccer. You're a girl, you play soccer, or you don't play soccer. And so this is all adds up to one. But if we ask a question, and the question is this: what is the probability of a girl knowing that you play soccer? Now here the question becomes probability of girl knowing that you play soccer. This is going to be probability of girl and soccer divided by probability of soccer. So probability of girl and soccer we calculated here, probability of girl and soccer. This is 0.24. So this will be 0.24. But what is probability of soccer? Probability of soccer is really just probability of boys playing soccer, probability of boys playing soccer, which is 0.12, and probability of girls playing soccer, which is also 0.24. So this thing here becomes probability of boys and soccer plus probability of girls and soccer, which becomes 0.12 plus 0.24, that is 0.36. So probability of a girl knowing that you are soccer becomes 0.24 divided by 0.36, that is 2/3. Another question is of a tree diagram question is this one, which is out of a class of 62% students pass in section 2. In section 2, so the only information you are given is that 62% of the total students pass. In section 2, however, 50% of students pass. So there are two sections, section 1 and section 2. Overall in the school 62% of the students pass, but from section 2 only 50% of the students pass, and 40% of total students are in section 1. Now before we go into the questions, we have to create a tree diagram. So let's try to create a tree diagram. So we divide it again into sections. So we start from here. We're gonna say section 1, section 2, and we know this information. We're gonna put the information we know here, that 40% of the students are in section 1. So this number should add up, so this is going to be 0.6. Now next thing we know are two things happens in section 1: they pass or they fail. Same thing, two things happens in section 2: they pass or they fail. Okay, so what do we know? What we know is that 50% section 2, 50% pass and 50% fail. Now we want to create this, which is probability of pass, and section 2 is going to be 0.5 times 0.6, that is 0.3, and probability of fail and section 2 is going to be 0.5 times 0.6, that is also 0.3. Now we need to fill this number. What is the probability of passing when you are in section 1, and what is the probability of failing when you are in section 1? So the total probability of pass is 0.62, right? So probability of pass is going to be probability of pass and section 1 plus probability of pass and section 2. So this is 0.62, so this will be 0.3, which is from here, plus this section x, so that is going to be 0.32. So probability of pass in section 2 is 0.32. So probability of pass in section 1 is 0.32, and so then you can calculate this part here, because probability of pass and section 1 is going to be probability of pass knowing that you are in section 1 times probability of section 1, these two numbers. So probability, we know that this is 0.32, so probability of pass knowing section 1 is x, and probability of section 1 we know is 0.4, so x becomes 0.32 by 0.40, which is 0.8. So this becomes 0.8, and these two numbers should add to 1, so this automatically becomes 0.2, and then you can also create this probability of fail and section 1 becomes 0.2 times 0.4, which becomes 0.08. So this becomes 0.08, and the other thing you have to do to make sure your math is correct is to then add this number up. So this, and this should all add up to 1, which they do. So you know your math is correct. And then there are some questions that they can ask. And so for example, you are asked a question: what percentage of students in section 1 pass the class? What proportion of students in section 1 pass the class? So what that is proportion of pass knowing that you are section 1. Now we don't know this information, right? We know proportion of pass in section 1. What percentage of students in section 1 pass the class? Which is basically this number, proportion of patients in section 1. But if you know this, you can also calculate this way, is the proportion of pass and section 1 divided by proportion of section 1. This is going to be 0.32 divided by 0.4. This is 0.8. The other question is, what is the probability of students? What is the probability of students who pass come from section 1. So this is probability of section 1 knowing that you pass. That is going to be probability of section 1 and pass divided by probability of pass. So probability of section 1 and pass we know is 0.32, so that goes to 0.32, and probability of pass we know is 0.62, so that adds up to